June of 2006, J&P were commissioned by the United Arab Emirates Ministry of Public Works to construct a new highway linking the Emirate state of Dubai with that of Fujairah. The project was split into two contracts. Contract 1 began at the Culvert-Sharjah Road. In addition to the Culvert interchange, Contract 1 featured a bridge for the safe transit of livestock and wildlife, a further interchange located at Siji, and an underpass which was situated at Sifni. Contract 2 began at kilometre 18 plus 800, and its main engineering features were the numerous culverts, reinforced soil walls, mountain cuts and rock fills. The end of the contract was at kilometre 33 plus 400. Although the first 9.5 kilometers of the existing unmade road were flat and relatively easy to negotiate, much of the rest of the existing route followed a deep wadi through the vertiginous mountains, only navigable by four-wheel drive vehicle. 6 teams of surveyors on Contract 1 and 5 on Contract 2, in addition to 2 GPS control teams, ascertained the horizontal and vertical route of the highway, much of it quite treacherous terrain. Red flags were used to show the proposed route. Following the demarcation and setting out of the planned road, activities on both Contracts 1 and 2 began in earnest in June 2008, with the first cut and fill operations. The earthworks were the major component of the project. They required the use of a variety of heavy plant vehicles. These included excavators for the majority of cutting operations, rock splitters to break up the larger pieces of material, and of course teams of bulldozers for the earth-moving operations. More than 300 heavy plant vehicles were employed on the project, their use split between the two contracts. For areas where the volume and density of rock was impractical for excavators and bulldozers, blasting was used. Prior to drilling charge holes, geologists and blasting engineers carried out extensive surveys to ascertain the composition of each area that required blasting, allowing for highly controlled operations. Once the holes were drilled at the optimum spacing and depth, they were packed with charged explosives by certified personnel, under the supervision of licensed blasting engineers. The local police authorities ensured each area was cleared and secured before the detonation of the explosives. After the blasting, the affected areas were re-inspected before further works could take place. Once the dust had settled and the areas deemed safe, trimming of the benches by excavators and removal of the blast material by bulldozers could be carried out. Each blast produced up to 8,000 cubic meters of material, the vast majority of it reusable as fill. This blast material was worked towards designated slopes, where it cascaded down to the load areas below. Here, excavators separated the materials that could be reused from material for dumping. This was then loaded into suitably robust tipper trucks to be taken either to designated disposal areas or to areas for required rock filling works. Each of the 120 tipper trucks used on the construction was capable of carrying 20 cubic meters of materials. amounting to loads of 40 tons. Even more robust off-road trucks were employed to handle the larger boulders. These were capable of carrying 60 tons of material. After the tipper trucks had arrived at the appropriate destination and offloaded their contents, the rock material was then spread by bulldozers into what would become, after compaction, 500mm deep rock-fill layers. Once their work was done, the graders were then brought into operation. These were equipped with adjustable blades that can be fixed at predetermined heights. This allowed for much more accurate leveling than could be achieved by the bulldozers on their own. The final part of the rockfill procedure was compaction of the hardcore by teams of ham vibratory steel rollers. At the peak of activities, 12,000 cubic meters per day of rock filling and compaction was being achieved. The recovered materials for providing the sub-base were mixed at convenient stockpile locations along the length of the project. These recovered materials were then loaded into tipper trucks for distribution to the required destinations. The tippers delivered the materials directly to where it was required for the laying of the sub-base. The sub-base layers were then leveled, graded and compacted to the required height. For this particular project, that was typically 500mm, and once again, graders and steel vibratory rollers were used for this process. The amount of dust created during these types of operations can be quite hazardous. The dust, however, was kept to a minimum throughout the project by 23 bowsers that continually provided water to dampen susceptible areas. There were a number of bridges, intersections and underpasses required on this project, all relying on the same general construction procedures. Once the foundations were in place and supporting columns cast, structural scaffolding was erected to support the bridge deck whilst it was under construction. The individual sections of formwork for the bridge deck were lifted into position by crane and then assembled by specialist crews. Following the installation of all the reinforcing steel and any necessary services, the bridge deck was cast and the concrete levelled in preparation for the specified road surface finish. Once the bridge deck was fully cured, the scaffolding was removed and any necessary works beneath the structures could continue. In addition to the bridges, there were 16 box culverts needed for the project, 9 for Contract 1 and 7 for Contract 2. The culverts were necessary primarily to preserve the flow of rainwater, preventing any damage to the local habitat. In some cases, however, they also function as underpasses to allow the safe traversing of the new highway. The box culverts were comprised of 4 by 4 meter cells, varying in size between 2 and 12 cells, and in length between 50 and 270 meters. All, however, were constructed using the table form method. Once the foundations had been cast, reinforcing steel was installed, along with the fabrication and erection of all necessary formwork. This was followed by the casting of the cell walls, and lastly, the roof sections. Once the structures were cured and all the shuttering and scaffolding removed, they were then ready for backfilling operations. Many areas of the project, including those surrounding the culverts, required elevation, mostly achieved using reinforced soil walls. Mortarless interlocking concrete blocks, 400 mm in length and 200 mm in depth and height, act as the retaining element. In between each layer of blocks, a PVC mesh or geogrid was then laid. In addition to being secured between the blocking, the geogrid mesh sheets were also held in place with the periodic insertion of small lengths of rebar. On top of the geogrid, a pre-wetted granular material with high frictional qualities was deposited, distributed, and then subsequently leveled and compacted to a depth of 200 mm for each layer. Once again, bulldozers, graders, and rollers were used for this segment of the process. Some areas along the length of the project required reinforced soil walls of monumental proportions, the largest area needing this treatment requiring an RSW reaching a towering 70 meters. This was built up over 3 separate tiers that required almost 400 distinct layers. To form a reinforced soil wall of these dimensions necessitated more than 30,000 man-hours, a fleet of heavy plant machinery, and 300,000 tons of backfill to achieve the desired road elevation. On this project, there were 35 reinforced soil walls of various scales, with their combined sides totaling almost 110,000 square meters. The final operation for the reinforced soil walls was the installation of the precast coping beams, placed on the ultimate layer of interlocking blocks. These were not only to give an aesthetic finish, but also provided added strength and integrity. Returning to the process of the road construction, once the sub-base layer was compacted, the next stage was constructing the foundation for the concrete barrier. This was done using formwork to a depth of 300 millimeters. Before casting, plastic sheeting was placed inside the formwork to ease with its later removal. The 6,900 concrete barriers required on the project were precast on site, with each 2-meter section weighing around 5 tons. These sections were lifted by crane and maneuvered into position by dedicated crews. The foundations had been cast with holes to correspond to rebar pegs on the underside of the barriers. These helped not only in initial alignment, but are also to prevent any later movement. Although average annual rainfall is not particularly high in the region, when it does rain, it can be quite sudden and ferocious. In order to divert the potentially treacherous waters away from the road surface to somewhere less hazardous, more than 100 concrete chutes, between 10 and 120 meters long, were constructed along the length of the highway. These were formed using shuttering, reinforcing steel bars and concrete, which was pumped directly to where it was required. Once the rough shape was achieved by hand, a slip-form sled was used for the final trimming of the concrete. This was designed and built by J&P, specifically for the purpose, and left a smooth, even finish, making for a more efficient water runoff. Another design structure for less severe water runoff was the 30,000 linear meters of stone pitching channels. The stones were hand-selected and laid by experienced masons before being grouted with a cement mortar. Before asphalting, a 200 mm base layer of wet mix needed to be laid. Guidelines were positioned and the required height confirmed by site engineers. The paving machines used have built-in sensors that take continuous readings and make any necessary adjustments to ensure a consistent depth of material and inclination of slope. Experienced engineers were always present during operations. One of their tasks was to take periodic inspections to verify the required inclination of the road. More than 300,000 tons of wet mix material was laid during the project. After laying, the wet mix was then compacted using teams of tyre and tandem rollers. The asphalt was produced at J&P's own site-located plant and delivered in 20-ton loads by tipper trucks. The project specified 2 base courses, each of 70 mm post-compaction depth, in addition to a wearing course of 50 mm that constituted the final layer. The paving machines were the same as those used to lay the wet mix course, and also made use of the sensors to provide accurate and consistent laying of the asphalt. At the peak of activities, on Contract 1 and Contract 2, up to 1,000 tons per day were being laid, the equivalent of 50 truckloads of asphalt. Again, tyre and tandem rollers were used to compact the asphalt to the required depth and density. Those sections of the highway that had embankments 5 meters or less required galvanized steel guardrails, which were erected by experienced 4-man crews. The vertical posts were installed every 3 meters using hydraulic post-driving machines. The horizontal lengths were then bolted securely to the upright posts. One of the penultimate stages of the project was to add road markings. The material used for creating the lines was powder glass, which is extremely durable and quite necessary given the harsh conditions found in the region. The markings were applied using 4 dedicated spray machines. The last operation of each contract was the installation of traffic signage. The overhead signs were mounted on cantilevered galvanized steel posts. These were fabricated by a client-approved local manufacturer and brought to the project in sections. These sections were then assembled in situ by experienced crews. Firstly, the 2 main sections of the post were bolted together. After this operation was completed, the gantry and framework for the signs were attached to the post. The finished post was then lifted into position by crane and firmly secured to the foundation by 12 25mm diameter steel bolts. All that remained was for the crew to position and secure the appropriate sign sections. The new road linking Dubai with Fujairah was given the official title of His Highness Sheikh Khalifa bin Zayed Freeway, but is known locally and more simply as Sheikh Khalifa Highway. The highway had its official opening on the 4th of December 2011, coinciding with the 40th United Arab Emirates National Day. However, the initial 17.7 kilometers, corresponding to Contract 1 of the project, was completed and opened to the public in December 2008, whilst Contract 2 was completed in May 2011. As mentioned before, Earthworks formed the major part of operations carried out on the project. On Contract 1, all of the 3 million cubic meters of materials cut was used for fill, with no need for disposing or borrowing of materials. Due to the much more mountainous terrain, Contract 2 required 14 million cubic meters of material to cut, with 11 million cubic meters of fill, leaving an excess of 3 million cubic meters that needed to be disposed. The vast majority of cut material came from blasting, with more than 1,700 different blasting events producing over 12 million tons of blast material. On Contract 1, 300,000 cubic meters of materials were used in the reinforced soil walls. This figure, however, pales when compared to the massive 2 million cubic meters of material needed for the reinforced soil walls on Contract 2. J&P are proud to have been invited by the UAE Ministry of Public Works to take part in this demanding endeavour, and have once more proven themselves capable of successfully meeting the challenges of a project of this scale. J&P, building the future for future generations.